All right, welcome to another chapter in the Security Plus series, which is also for the cybersecurity students. And this chapter, which is chapter 11, I'm going to look at securing specialized systems. Again, I will also use my slide deck to go over the slides. I might have to slow down a little, so it might not be possible to finish this in under 30 minutes, but I'm going to try. Uh, Basically, because some of the concepts here are obviously important. But I'm just keeping through the contact information. You can freeze the video and check it. Follow me, my bio, copyright information. So here, the whole idea of chapter 11 is for me to talk to you or for you to learn about how to secure your host and your devices. And of course, definitely how to secure mobile devices and their connections. These are important cybersecurity concepts and also very important for your Security Plus exam. I said before, I've taken the Security Plus exam more than over 8 years ago. But also I've been teaching this particular CompTIA certification for a while. There was a time in which I was helping people with disability to read the exam content. So when you do that, you have to agree to not teach the modules. But I'm a CompTIA certified instructor and also a partner. My company is a partner. So this module is divided into module A and module B. In module A is just about securing host. Here we talk about hardening your host configuration, choosing the appropriate security software, and how to create and enforce security baseline. So when you're talking about system hardening, making it stronger, we talk about stuff such as list functionality, secure configuration, how do we control the applications, the software we're having, and definitely patching and then logging and monitoring what is going on in our system. When we talk about secure system design, the whole idea is what is called a trusted computing base. This is not just about hardware, but it's software, firmware, which is obviously software embedded in the hardware. Because many times attackers are looking for how to get around the trust relationship in the system. So preventing attack basically has to do with hardening the TCB to prevent its alteration. This was a concept that was defined way back almost 40 years ago. But of course, operating systems are a little much more complex than that. I started my career in computer science 2 years later in 1985, so a lot of things have changed. So how do we harden our system? But also our operating system, that was just about security design. If you want to configure your host operating system, you need to make sure you configure in a secure way to reduce what's called the attack surface. Obviously, say the step one is to make sure you choose an operating system that is designed securely in the first place. So most government, especially the US government, they publish what is called a trusted operating system standards. The most common one is the one defined by ISO 15408. Most will rarely see that ISO standard. But the point that every operating system must have its own security module. But security design system, they have like a multiple privilege levels, like a simple division between what the user processes are doing and what the system processes are doing. So you've heard of Windows and Mac, but also in Linux, the security module LSM. Now, the NSA back in 2000, 25 years ago, came up with what's called the Security Enhanced Linux, the ED1 SE Linux. Then 3 years ago, it was merged into the mainline Linux content. So this secure Linux has been also added to other what we call Unix-like operating system. This is something that I was working on way back in the 80s, Unix systems, and most people don't have interaction with that. But for example, Android 5.0 and higher uses this security enhanced Linux. So I call it C Linux, right? Even Solaris and then the trusted BSD all have this. Now, for Windows, going back to Windows, that most of you might be familiar with, the password policies, they can be enforced through like group policy object GPOs. Stuff like your password history, the maximum password age, minimum password age, the length of the password. I think when we were talking about password, I believe in maybe earlier chapters, where we talked about sorting and peppering, we looked at NIST standards for password length. Here you must like enable the complexity requirement, which is small characters, like caps, numbers, special characters. Also, when we're talking about application controls, we basically need to monitor the applications that are installed and used and make sure we prevent them from damaging our system. That is the reason why we always recommend that you have at least two accounts on your system, the admin account and then the regular user account, and you install all software using the admin account, and then you do your normal day-to-day work in the regular user account. But what many systems do is these two terms here you need to understand. Blacklisting or blocklisting, which is a new terminology, whitelisting or allow listing. So blacklisting is an implicit system that has a list of forbidden programs, and those programs cannot execute on the system, as opposed to whitelisting that has an implicit deny system that stores the same approved list of programs that are allowed and blocks execution of any other program that is not on the list. I don't know if you ever try to like run a program and it gives you a warning sign. Maybe the code has not been signed or it doesn't understand the certificate, or I think the certificate may have been revoked. So this is part of code signing, but it's good to say that code signing doesn't really verify that that software is safe, because it could be in the supply chain, but it just verifies that the signing party claims that it's safe, and the certificate authority trusts the signing party. So it just gives you protection if the operating system is configured to check for signatures and block or give notifications when you want to run an unsigned or untrusted program. For hardware security features here, we want to remember when we talk about hardware, we sometimes have to talk about firmware, which is software embedded in the hardware, right? Like even BIOS. So you should have stuff like what's called executable space prevention. This is a CPU feature that basically allows memory regions to be marked as non-executable. So it prevents what we call like buffer overflow. And a secure boot in the modern systems is a firmware feature, right, that uses the same public key infrastructure, prevent like rootkits. We talked about rootkits a few chapters before, or the TPM, which is a chip that could be installed on your motherboard, or nowadays one of them are actually embedded inside the motherboard chipset. This is for storing your cryptographic key. And if you remember that I said in one of the other videos that if you don't have TPM, you will not be able to install like Windows 11. That's a requirement. All right. So your endpoint device, like my laptop, my phone, just anything that I'm using at the end of the system, not like a network device, you need to make sure you have antivirus on the host-based firewall, some kind of browser protection, email protection, and then the host intrusion detection system, and something that checks file integrity monitor, and definitely a DLP for data loss prevention. But there's also a benefit to having centralized endpoint security. This way, I can identify and track what is happening across my network. This will monitor email attachments that I send over my network. You can scan for the malware that we can use for like when we are trying to check our VPN or remote connections. You also look for potential malware targets, and of course, do what's called advanced malware analysis on your system. So there's a benefit to having not just on your endpoint, but more like having it centralized. For the endpoint detection and response, you will hear words like MPP, MDR, XDR, like extended detection and response. Just have an idea about what the distinction might be. the MPP, since it's extended through the whole life cycle of threat management, as opposed to the XDR, that's a further extension that looks at the endpoint, your servers, your network, cloud workloads, and all other data sources in the enterprise. Security baselines are very important, but if I don't have a baseline, how am I going to know when I'm deviating from that, right? So when I want to establish baselines, I'm going to think about operating system configurations, making sure I have antivirus, firewall, HID software, what are required and disallowed applications, as in the block list, allow list, settings from application, patch levels, physical security, and of course, a user training procedure. Some organizations, just telling you, a security standard organization are always looking for how to advise or apply controls on how to harden your network. So just check this CIS security website and look for like benchmarks that talks about workstation, server, mobile operating system, web browser, and other desktop applications. So, for example, now if you have security template, I can look at this. See, this is a security template. I open it in Notepad. This is for Windows 2012 server running IIS. It tells me a few things that I need as a template that I can use for my own system. So how do we plan to harden our system? How do we do the configurations? One thing you need to do is make sure you understand the importance of documentation. Well, let's say any network administrator needs to understand all systems, all devices on your network. Make sure you don't have rogue devices, whether it's just a rogue access point or just rogue, it could be a rogue router, or somebody plugged something that is not supposed to be there. Even a desktop that you're not supposed to have on your system. You see a desktop is in the reception area, wasn't supposed to be there. So this is to avoid stuff like shadow IT, sprawl. Configure all user accounts according to the doctrine of least privileges. Disable unnecessary software. You hear the word bloatware. Use encryption. Ensure that the operating system version you're using is supported and receives a security update. If not, then apply what's called compensatory controls. And again, definitely apply all your patches. If so, it says establish specific security requirements for devices that aren't permanent part of your LAN, as in your local area network. And definitely have baselines. You have documentation if you ever change your baseline on your system. All right, so how do we, when we're trying to secure clients and endpoint, again, remember the doctrine of least privilege. So it is hardest to apply to client, but you need to apply it on client, but it's very, very important, right? Make sure that endpoints these are physically accessible. User applications are a primary target of endpoint attacks. So just make sure that those apps are secure, they are patched. Sometimes users leave their devices unattended. Could be for laziness or whatever the reason is. Just say make sure you configure them to lock when not in use, especially like at the receptionist's desk. She goes off to the bathroom or secretary. Just make sure that you have some way of securing them and also, of course, preventing shoulder softening. Now, how do we secure mobile devices? If you heard of the word routing or jailbreaking, most people think it's only about Android, about iPhone, but basically it's a way for you to change security configurations on a device. Like I make an iPhone work like an Android, or if I'm doing forensics analysis on an Android, I root the device. You just say don't allow it, especially for devices that are used for sensitive purposes. Again, we talked about configure screen locks using strong password or biometrics. Encryption. It's very, very important to use MDM, mobile device management software, to centrally manage your devices and only install approved applications from trusted sources. And we see already social engineering there to avoid like shoulder softening. So how about our servers? the devices that we have that provide the resources to other computers. Enforce, again, list functionality, configure the services securely, use strong access control. It says keep them and their processes logically isolated if it's possible. And of course, monitor server access. That's why to get into a server room, you should have biometrics, password, have cameras looking down there. And of course, back up your critical data in your server so that you can have access to it, right? And we don't have part of the violation of the CIA triad. So now in virtual systems, it's always good to plan the deployment of your virtual machines. I've seen situations where enterprises, you've got so many virtual machines, you got a Windows 7, Windows 10, you're using that for testing, but you have so many there. You have the VM sprawl. Just make sure that all the VMs are hardened. Make sure that every